Hey guys, so happy Halloween. You guys just left a few minutes ago, and I figured I'd go ahead and do lesson 6.3 with you guys. That has to do with slope. This is going to be the last video of your homework for this weekend, this Halloween weekend. Hopefully you guys had a really fun Halloween. And so I wanted to just film a very quick introduction for you guys so that you guys can see my face, because sometimes people learn better just from seeing the person's face. So I figured I'd go ahead and, at least debut myself. So let's go ahead and get into your lesson. Alright, so we are going to go ahead and we are on page 171 of your textbook. And so our essential question for this lesson is, how can you describe rate of change in real-world linear relationships? Okay, and so first of all, you guys can see here that you have, we're going to skip, by the way, this explore activity just because I feel like it's a little bit repetitive. But rate of change basically is exactly what it says. It is how something is changing. And so this is something you guys have done in the past. You have definitely discussed rate of change in 7th grade and in 8th grade. So you should already be aware of what it means. But just in case some of you forgot, it's the exact same thing as slope. But sometimes you guys prefer the word rate of change because it seems a little bit less scary, I guess. But rate of change is the change in y. So how is your y value changing from one to the other? And how is your x changing as your denominator? Okay, so this, like I said, this is the exact same thing as slope. Okay, so we're going to go ahead, we're going to flip the page, and we're going to come down to halfway on page 172. Okay, so when you're dealing with linear functions, which is what we're going to be discussing the majority of the time for module 6, you want to make sure that your rate of change is constant. Okay, that is the only way that you are going to have basically a straight line. And in order for you to know that it's constant is obviously by looking at your line. Okay, if you have a line, you know that it has a constant rate of change. The other way of finding if it is constant is if you have like an x and y table. So I'll just do a little one over here. Okay, if you have like an x and y table like this, you want to make sure that your numbers are changing by the same amount. So you want to make sure that all your y values are changing by the same amount and that all of your x values are changing by the same amount. Okay, that's how you'll find it, or that's how you'll know if it's going to be a linear function, is by looking at those x and y values and making sure that they're the same. Okay, so when we are looking at rate of change on a line, okay, we're going to be using rise over run. This is something that, again, you guys should definitely be familiar with. Okay, so the rise over run. So your rise is obviously up or down. So you guys can see that to go from this point to this point, you need to go up 1, 2, 3, and then to the right 1, 2. And that's how you get a slope of 3 over 2. But if you wanted to use this point and this point, for example, you see that you have to go up 1, 2, 3, 4, 5, 6, and to the right 1, 2, 3, 4. Okay, if you have 6 over 4, if you simplify that fraction, you still end up with 3 over 2. So it does not matter which 2 points you use, you'll still end up with the exact same slope. Okay? So we have here your slope equals rise over run, which is the exact same thing as the change in y over the change in x. Okay? Now, your textbook basically it's showing you 2 different ways of finding the slope of a line. I'm going to go ahead and tell you that I would prefer, and it will make your life much easier if you guys stick with rise over run and not going down and to the left. If you go up and to the right, it just makes more sense, because I have seen that it can get very confusing, and mostly because of the sign of whether it's going to be a positive or a negative. That's where I see that students end up making the most mistakes. Okay, you guys can see here that in blue, it's talking about this line right here, okay, these lines. So you see that to go from this point to this point, you need to go down 1, 2. So going down is negative 2, and then to the left is negative 1. Okay, so you guys can see here that that's negative 2 over 1, which when you simplify gives you the positive 2. Okay, but if you look at the line in green and the explanation over here, you'll see that it says that it doesn't matter, which is true. It does not matter which method you choose. However, rise over run and going up and to the right is typically the way that most of us do it. It's what makes the most sense, I think. But again, choose whichever method you'd like, whichever one makes the most sense to you. So you can see that from this point to this point, it's up 1, 2, so positive 2 over positive 1. And positive 2 over positive 1 gives you positive 2, just the same as with the other example. Okay, now with example number B, letter B, you guys can see that from this point to this point, you're going to be going down 1, 2, 3, 4, and because we're going down, that means negative 4. Okay, and then to the right, 1, 2, 3, 4. So you see negative 4 over 4, and when you simplify that fraction, you get negative 1. Okay, so that is exactly how you find slope of a line when you have a graph. So now, when you're talking for this one, this your turn question, a lot of times when you'll see this, they won't actually tell you which points to use, so you'll have to find your own points. And when you have to find your own points, just make sure that they're crossing on this little part, okay? You don't want to choose a point that's right in the middle because you don't know the exact value of that x and y coordinate. Okay, so always choose a point that's right on the middle. So you see that this is crossing exactly here and this is crossing exactly right there. Okay, so let's go ahead and find our slope for this line. So to get here, we need to go down 1, 2. So down 2 is negative 2. And then to the right, 1, 2, 3, 4, 5. So it's going to be negative 2 over positive 5. And that's going to be your slope. It's pretty simple if you ask me. I'm going to switch over to a different math book right now just to give you guys another example. Okay, so over here, you guys can see, and by the way, we're going to be talking about this formula in a minute. This is your slope formula, okay? But here you have 2 points again, and again, you're just going to go up 1, 2, 3, 4, 5. So up 5, and then to the right, 1, 2, 3. So up 5 and to the right 3, and you see that the slope was 5 over 3. Okay, and so you get 5 over 3 using this formula as well. Okay, and again, like I said, we're going to go over that in a second. So going now to page 174. Okay, I skipped the explore activity a little bit, but I do want to mention this right here. Okay, this is something that you need to know. You need to memorize this. You need to know it. Okay, positive slopes go upward. Okay, notice that from left to right, if you're going this way, it's going up. Okay, and if it's negative, again, if you're going this way, it's coming downward. Okay, so positive goes up, negative goes down. Those are the ones that you guys are usually pretty okay with. Okay, but now to know the difference between a zero slope and an undefined slope. Zero slope has a horizontal line. It has a Z for 0. Okay, undefined goes up and down. So up and down for undefined. Okay, it's a vertical line. So horizontal lines, Z for 0, and undefined goes up and down. Okay, you need to know this. So now let's go ahead and jump into our slope formula. Okay, so slope formula, basically all you need to know is this. Okay, so you have M equals, and M, by the way, you need to know M equals slope. Okay, you need to know that M means slope. So M equals y2 minus y1 over x2 minus x1. So what that means is you're going to be using the 2 points. Either they will give you 2 points or you will choose any 2 points on that line, and then you're going to go ahead and substitute the y's for the y values, okay, and these x's for the x values. Okay, so typically you're going to go this number minus this number, see, y2 minus y1, and then this value minus this value, so x2 minus x1. If you wanted to, and I'm only mentioning this because I feel like I should always give you every method of doing something. If you wanted to, you can do this y minus this y, and then this x minus this x. That is perfectly fine. You will still get the exact same answer. The problem is that when you switch it up like that, sometimes students tend to make a mistake, and you'll do this y minus this, and then accidentally do this x minus this x. And then when you do that, you're going to get the wrong slope. It'll give you the wrong sign. So you'll get a positive when it should be a negative, or it'll give you a negative when it should be a positive. So you need to make sure that if you're going to do this point and then minus this point, that you're always sticking to that route. So notice that these are 2's minus the 1's, basically. Okay? So in this second example, it says to find the slope of the line passing through points 5, 3, and negative 1, 15. It says to describe the slope as positive, negative, 0, or undefined. So you see here that they did y2 minus y1. Okay, so 15 minus 3, and that gives you 12. And then your second step is to find the run, which is going to be your x value. So we'll do negative 1 minus 5. And so negative 1 minus 5 gives you negative 6. So when you come over here and you substitute that into your rise over run, you have 12 divided by negative 6, which gives you negative 2. And so your slope is going to be negative. Okay? Now, going back to this very, very quickly, a horizontal line